The technology platform for cultivation in microtiter plates was originally developed by Wouter Dütz and his research group at the Institute of Biotechnology of the ETH Zurich at the end of the 1990s. The original purpose was the rapid screening of their collection of 2,000 wild-type bacterial strains for the presence of certain enzyme activities. Later, the system was also adopted for the cultivation of mutant libraries, streptomycetes and fungi, and the production of their secondary metabolites. Between 2005 and 2010, the system started to be increasingly used for the cultivation of animal cell lines, such as CHO cells. Sandwich covers are the heart of our cultivation system and consist of the following components: a rigid stainless steel part, which gives the cover the necessary rigidity, 2 filter layers to prevent airborne contaminants to enter the wells, a microfiber filter, and an expanded Teflon filter. Here you see the expanded Teflon filter. The last component is a silicone layer with small holes above the center of each well. The main purpose of the silicone layer is to prevent cross-contamination and to limit evaporation. The size of the hole determines the supply rate of fresh air to the culture and also the evaporation rate. In these standard sandwich covers, the size of the hole is chosen to result in an exchange of headspace air rate of 1 to 2 culture volumes per minute, which contains sufficient oxygen for even the fastest growing bacteria. We also have sandwich covers with smaller holes, and so a slower exchange of headspace air. These are meant for long-term cultivations of slow-growing strains and cell lines, with cultivation times of 3 to 14 days, for example for animal cell cultures. This limits the evaporation losses to less than 1% of culture volume per day. We supply sandwich covers for a wide range of different microtiter plates. In the introduction, we already showed the square 24 deep well plate. It is the most versatile and most widely used microtiter plate, and it allows culture volumes of 2 to 4 milliliter. These plates are available in reusable polypropylene and since 2011 also in disposable polystyrene. As said in the introduction, we have sandwich covers with large holes in the silicone layer for fast-growing strains, and a version with smaller holes for slow-growing cells. We also have special covers for Corning 24 round well plates that allow culture volumes of up to 1 milliliter, both in a normal and in a low evaporation version. The latter type of sandwich cover has an extra layer, a thin stainless steel foil with a tiny hole of 0.2 millimeter above the center of each well. This kind of sandwich cover is especially suitable for animal cell cultivations. As said, these covers are only applicable for Corning microtiter plates. For other types of low well microtiter plates with 24 wells, we have so-called universal covers. These are also available in a normal and a low evaporation version, both with spongy silicone inlays and, as in this cover, with a solid black silicone layer. We also have sandwich covers for 96 well microtiter plates. They are meant for reusable polypropylene deep well plates, which we supply as well, flattened and detoxified. These sandwich covers are compatible with all types of 96 deep well microtiter plates commercially available. For polystyrene round well plates, we have this type of sandwich cover. It has 5 positioning pins that fit in the spaces between the round wells. This type of cover also has a stainless steel foil with tiny holes in order to further limit the exchange of headspace air, and so also further limits the evaporation. For low square well microtiter plates and for other types of plates that do not have open spaces between the wells to accommodate the positioning pins, we have universal covers as shown here. We supply 2 types of clamp system. One, as shown here, is specifically meant for deep well microtiter plates. The inoculated microtiter plate with a sandwich cover on top is slid into position like this. Then the handle is turned. The turning of the handle causes the sandwich cover and the microtiter plate to be pressed together. The silicone layer is pressed tightly onto the microtiter plate. This ensures that there can be no occurrence of cross-contamination, not even during vigorous shaking. The second clamp system is a universal clamp system. It still allows the clamping of a single deep well microtiter plate, but it is primarily designed to clamp multiple low well microtiter plates on top of each other. For this purpose, all sandwich covers for low well plates have spacers as shown here. This allows you to stack the next microtiter plate on top and still have a layer of air in between. In this way, aeration rates and evaporation rates remain equal in all wells. Here you see how maximally 4 96 low well microtiter plates can be stacked. The stack of microtiter plates, including their sandwich covers, can then be tightly screwed together using the tightening device as shown here. The same story for 24 well plates, with the sole difference that only 3 plates plus covers can be stacked in one position, because these microtiter plates are higher. For the purpose of this video demonstration, we have shown the use of the two clamp systems on a normal table. In usual laboratory practice, the clamp systems remain attached with screws to an orbital shaker platform inside a temperature incubator. The ground plates of the clamps have different hole patterns for different shaker types. The hole patterns are compatible with shakers from Kuhner, Inforce, and New Brunswick. The shaker cabinet does not need to be humidified for most purposes. The culture evaporation rates are usually already sufficiently limited by the sandwich covers. If the evaporation rate should be further reduced, we advise to apply no higher humidities than 75%. Higher humidities lead to fungal growth inside the shaker cabinet and may as a result negatively affect the health of laboratory workers.